All right, how's it going? Pretty good. All right, I want to start by talking about some PA5 stuff, some Zenity stuff. I had a bunch of questions from people, and I posted some things on the announcements to try to help with those, but let's go over what some of you may be running into. So, presumably you're doing something in PA5 where you say something like this. And you may have other things, title and things like that, but you're using a Zenity dialog box to have the person input say their name. And Zenity will normally output that name, and so you put it in back quotes and you assign that to a variable. And the hope is that after the person types their name and hits enter, you have a nice variable with the person's name in it, right? And you have a reservations file that has stuff in it, and you'd like to know if this person already has a reservation. So you're doing something like grep $name reservation.txt, and annoyingly it doesn't find the record, right? You do this and then you echo the status and it's non-zero, which means there's no record in there with the name Nick, even though $name is clearly equal to Nick, right? So has this been happening to any of you? Right, so, and if you say grep for Nick, we'll even put it in quotes, in reservations.txt, it definitely finds it. And then if we look for the return status, it's 0, saying there's a record in there. So the reason this is happening is if you're running under Windows or under Cygwin, things are not what they seem. So my first suggestion to people has been, really from the beginning of this course, when you're trying to examine the value of something, throw it inside delimiters. So do something like echo, double quote, doesn't matter what the delimiter is, I'm just going to use angle brackets. But it could be anything. The goal is, if there's extra stuff at the end of $name, you're not going to see it when you echo. Because I don't know if echo returned 4 characters or 4 characters followed by a bunch of spaces or a tab or things like that. So by throwing it inside a pair of delimiters, I'm hoping to get a better idea of seeing exactly what this variable looks like. And as soon as you do that, you start to notice something, which is that something weird is going on. Because I should get a less than sign, Nick, and a greater than sign, and instead I got a greater than sign followed by Nick. And that should be a big red flag to you that something weird is happening. So part of the joy of working in Linux is that you can interact with the environment, right? I've got a variable and I'm searching for it in a file with grep and it's not working. You don't have to just throw your hands up and say grep's broken, or I don't understand grep, or I should be an art major, right? So you can start digging into what's going on, and one way when a program's not working correctly is check the inputs, right? So if this grep line is not doing what we expected it to do, check the inputs to it, okay? Check $name. And delimiters are just one of these tricks that you learn eventually, and sometimes they help, sometimes they don't. Okay. So another trick is to use a command like octldump, od. And od is a way to look at a file as a bunch of octal ASCII codes. So if I say octldump res.txt, it shows me the contents of my file with a bunch of meaningless octal codes. Okay, that's not very satisfying. But with the -C switch for character, it says show me the contents of my file as a bunch of printable characters if possible. So now if I say octldump -C and I give it, say, a file name, it shows me the contents of my file character by character. But some of the characters, like at the end of this first line, it prints out a \n. Okay, this is actually an ASCII code 10. And ASCII code 10 is not, well, it's printable, but it comes out as a new line, which is why when you catch your file, it just goes down to a new line. But we can actually see what's happening in here, right? There's a character 10. Say what?
So it prints out the ASCII characters as character.
Prints out ASCII characters as character. It prints out some non-printable characters with a pattern that we'll recognize, such as \n, or a tab would come out as a \t. And if it's got bunches of non-printable things, it'll just print out as a 3-character ASCII code in octal. So this file, which was a GIF file, right, is mostly non-printable stuff. \b is a backspace, ASCII code 8. This is just the letter, the character 8. This is the character U. This is ASCII character 034 octal. 24 plus 4, it's ASCII code 28. But it doesn't throw things off my screen or change my video to reverse video or anything like that. It's a nice controlled way to look at something when you're not sure what the content should be. So I can say echo $name, and let's pipe that into octaldump-c. And now we immediately see what's going on. The first character output was in fact that less than sign, followed by NICK, followed by this \r, followed by the closing delimiter. So that tells us something really important. It tells us that name has got 5 characters, NICK and a \r. So judicious use of delimiters and the OD command makes this pretty apparent, right? So the next question is, why is there a \r in there? And there's this \n at the end. While echo, remember, if I say echo hello, it doesn't just say HELLO, it says HELLO followed by a new line, right? So if I take that and I put it into octaldump-c, it shows me this command outputted HELLO followed by a new line, right? And these things on the left, these are just the addresses, right? It starts from 0 and counts up. Now if I say echo -n, it suppresses the new line. So it printed it out and it didn't come down to a new line before it printed my prompt. So if I do that and I put it into octaldump-c, it output exactly 5 characters. So if I echo -n $name and put that into octaldump, we see only the characters making up this variable name, and it's clearly NICK followed by this \r. Okay, so why does this happen? Because Windows does something kind of quaint. It puts 2 characters at the end of every line. It puts what's called a carriage return followed by a line feed. And Linux just puts a line feed. So how many people here have used a physical typewriter? Cool. I just saw a place they sell like a USB keyboard, but it's got typewriter keys on top. It's like really cool. It was like $200. So a carriage return means, so you're typing on a typewriter, right? And if you haven't used one, there's this piece of metal that you press a key and this piece of metal comes swinging up and it's got a backwards impression of a character on it. And it hits a ribbon with ink and it pushes it against a piece of paper and it makes an impression of a letter, right? And you release the key and the lever falls back down. You press a different key and a different lever comes up and hits the ribbon and makes another imprint, right? And as you're doing this, the thing that's holding the paper, which is called the carriage, is moving to the left, right? So that the thing that's making the imprints of these letters is always in the same spot in the universe, but the paper is moving to the left, so it's effectively printing to the right. When you get to the end of the line and you want to go back to the next line, you take the carriage, which is carrying the paper, and you say return it to its original position. So a carriage return is really just going back to column 1. Okay? And a carriage return technically does not move you to a new line. If you want to move to a new line, you take that carriage and you scroll it, that's a line feed. And if you're over here on the paper and you do a line feed, technically it doesn't move the carriage back to the beginning, it just scrolls the paper up. So technically these are two separate operations, right? Carriage return says go back to column 1, line feed says go down to a new line. So on Windows, these are separate. On Linux, they said, well, we don't need 2 characters for that. So you just use a line feed and it implies go back to the beginning, scroll up 1 line. But we still live with this difference and we suffer with this difference today. So a carriage return, this is ASCII code 13, which will also print as a control M. So if you're seeing control M's in your file, that's the carriage return, right? So control A is the first letter, that's ASCII code 1. Control B is ASCII code 2. Control M is 13th letter, ASCII code 13. So it shows up as a caret followed by an M. And in Linux, it's displayed as a \R. A line feed is ASCII code 10, that's a control J. And in Linux, it's a \N. So what you're seeing is just an artifact of the feature of Windows that Zenity is trying to terminate this string, and so it throws a carriage return at the end of it. And that's what's tripping you up in dealing with things like grep. Okay, so that's the longer version of why we have this \R. What do we do about it? We get rid of it. Okay, every time that you use Zenity and you save the return from Zenity in a variable, if it's got this \R in it, let's just get rid of it. Well, how can we do that? Well, sed, right? So we talked a little about sed last week. Sed lets you put in a substitute pattern in here. So we can say substitute / something with what we want it replaced with. So if we search for a \R and we replace it with nothing, that deletes the \R. So let's play with this. So let's just say sed substitute with x with nothing. And if my input is hexadecimal, it changes it to head decimal, gets rid of the x. Okay, so we can use that kind of substitution pattern to get rid of the \R. Right, and that's all we need. Substitute / \R, which means carriage return, and replace it with nothing. So if I echo $name and I pipe that into sed, and I put that into octal dump, right, we got rid of our \R. So now I can do that same echo command, but I'm going to throw it in back quotes. I'm going to take the result of that and stick it in a variable called new name. And new name should look like name, but it should have that \R removed. You got to spell it right though. So there's new name. Let's put it in delimiters. Still spell it right. All right, so that looks better. We can put it into octal dump. That looks fine. And finally, we can search our reservation file for new name. There's the record. So something like this, every time that you get a result back from Zenity, will take care of your caret M blues. So over here, if you did this with name, and you can use the same variable name. So back quote. I would put this inside double quotes, just in case it's got spaces and stuff. Pipe into said, single quote, substitute slash backslash r slash slash, end single quote, and then a back quote. And that's a scribble, don't put the scribble in. All right, so these two lines should get you something from Zenity and then sanitize it. And if you do that every time that you call Zenity, right, that should take care of that issue. All right, the other detail is this business of getting rid of an existing reservation. So let's say this is your reservations.txt file, and you've got a bunch of reservations in here, and you get a new reservation for Tina, right? And you grep for Tina, and Tina's not found in here, right? You don't have to do anything. It's a new reservation. You can just take your new record and append it to the bottom. But if the person says their name is Nick, and you search in reservations.txt for Nick, you're going to find an existing record, right? And when you do this grep, if you look at $? It's a 0. That tells you the record is in there, right? So if you're doing a grep, typically you can throw that into null so that you don't see the record, but then just check $? 0 says, uh-oh, Nick already has a reservation. So you can use the -v switch, and that reverses grep. It says, show me any lines that don't match this field. So if I grep -v for Nick, right, that shows me all the records. New name. That shows me all the records that don't match Nick. So what do you do with that? Throw it into another file. And now res2 is my reservations.txt with that person's record removed. And then copy that back onto res.txt, and you basically deleted the record. And make sure you're searching for, right, beginning of the line, followed by the person's name, followed by a pipe. Otherwise, if the person's name is Ni, it's going to think that they've got a reservation. Or if their name is sometime. Okay, does that help? I think those are the two main things that people have been pondering for the past few days, was the caret M's and how to deal with the reservations file. So those should get you most of the way. All right, so any other questions on PA5 or the lab or anything? Yeah.
For the lab, I was wondering, it says to use useLeap. Would there be any problem with using delay instead?
I don't know delay. What is delay?
It's under GitLab library number, but it doesn't give you a compiler.
Okay, that's fine.
It's the same thing though.
Okay, as long as it works, I'm happy. Yeah.
So, okay, sorry.
Okay.
What's the difference between the one that has the caret and thing and the other one?
Oh, so here's our reservations file. right? And if I'm looking for Nick, it finds that just fine. Suppose my name is equal to Knee, and I search for that in the reservations file. It brings up this record, right? But this is not Knee, this is Nick, right? So if you search for beginning of the line followed by a name followed by a pipe, that will only match a record that begins with NI followed by a pipe, right? So it won't pick up partial names. Or if my name happened to be sometime, right, it would match all of these records because each of these records contains sometime. So this is saying I'm not just looking for $name, I'm looking for the beginning of the line followed by $name followed by a pipe. That's going to force it to match this right here. So if you have users who are troublemakers, it keeps them from causing too much trouble.
Okay, so that tells that you're looking for beginning of the line and then
Followed by whatever the name is, followed by a pipe. But we can still get into trouble. Right, if my name happens to be Nick Pipe somewhere, it's going to mistakenly find this record, which is actually a reservation for Nick. But now you got a real troublemaker, so just delete their files and be done with them. All right, any other questions? Yeah.
So to split up the data, I know that like you went over like the other class, but like so I think you said something I'll use like the command echo %d with inside quotes, right? But whenever I try to actually print it out again, it just prints out %d again. So I'm not sure if like, the quotes aren't supposed to be there.
So let's get a date. Okay, so there's the date we're working with, right? So it's definitely $, not percent.
$.
Yeah.
That's probably what's going on.
Okay, yeah, try it with that. And so again, if you want to split this up, sed's probably a good way to do this. So if I wanted to find the day of the month, which is this middle part, so there's the month slash, there's the day. And let's just replace all of that with the day, right? So there's our 26. So you can put that in a variable, right? So hopefully everybody uploaded their SLP posters. Those are on the way to the printer. If you didn't upload, please go ahead and upload. I open it up again for another 2 days. If you don't upload it by Wednesday at 8, it'll be 0 points. So please upload it. But you'll have to print it on your own if you didn't already upload, if you want a copy of it. Otherwise, we'll have posters for you next Tuesday. All right, so let's talk about SED. We talked mostly about awk at the end of last week. Awk is really designed for manipulating individual fields within each line of a file. So you've got a file that's comma separated or space separated or something like that, and you want to do something like swap the first and second fields. Or take the second field and print it out, followed by the third field, followed by the fifth field, right, without the fourth. Or something like that. You want to see if this third field has some pattern to it. It's really sort of reading in a file line by line and doing things within each line, usually based on columns or fields. SED is kind of a line-based version of a file processor. It's really designed to do things with individual lines, see if the line matches some pattern. If it does, print it out twice, or don't print it out, or print something out before it, or things like that. So awk is kind of field by field, SED is kind of line by line. And it looks very much the same as awk. SED is the name of the command. There's a program. and then there's an input file. And the input file is optional. If you don't have an input file, it just reads from standard in, like most things. So I'll use brackets for things that are optional. It's just how the manual pages work too. So sed program and then an optional input file. And your program is a command line argument, but if you have a more complex program, you can put that in a file and then say sed-f and then the name of the program file. And then the optional input file. And sed's default behavior is to read from the input, either the input file or standard in, and copy the output to standard out. Okay, possibly modified by the program. But it basically reads from the input, copies to standard out. If you do a -n switch, this says don't copy from input to output. It suppresses that default copying behavior. If you do a -i, it says replace the input file with the output that's produced. So normally sed doesn't touch the input file, it just reads from it. If you do a -i switch, whatever changes you ask it to make actually get applied to the input file, so you can actually do editing. So your program looks like this. There's an instruction. And there's an address and an address. But those are optional. You can have a single address which says at this line of the file. Or you can have a pair of addresses which says anywhere in between that first address and the second address. Take some action. And so your address could be a number, which is a line number. Could be a $, which is the last line. Or it could be a / regular expression. And your instruction can be things like P for print, D for delete, Q for quit, A for append, I for insert, and there's other things. And we'll play with these presently. Okay, so most basic behavior for sed. So here's our foods file. Sed, empty program foods, copies from the file foods, sends a copy to standard out. So it's a big glorified version of cat. Sed-n, empty program foods, does nothing. Why? Because we suppress the default behavior of reading the input and copying to standard out, and our program doesn't do anything. It's an empty program, quote, quote. If we make a program P which says print, and we don't specify a pair of addresses or a single address, then it says on every line of our input file, let's print it. So we're back to a fancy version of cat. If I say 1P, that says if this is the first line of the file, print it. So now I've got a way to read the first line of a file. If I say $P, it says if this is the last line of the file, go ahead and print it. If I say 2,4, it says if the line of this file is somewhere in the range 2 to 4, so it prints out the second, third, and fourth lines. If I say $1, I got another version of cat. Yeah.
Isn't the N supposed to suppress that?
If I don't say N, I get each line twice. Why? Because without the dash N, the default behavior is read from the foods file, copy it to standard out. So that said burger meat. And then I said if we're on a line somewhere between the first and last line, print that line, so that printed the second occurrence of burger meat. So the dash N is tricky, right? And I forget it at least half the time that I do this stuff. And more often than not, you want a dash N because you want to control what's being output, but sometimes it's convenient to take that default behavior. All right, so if I do sed dash N slash fruit print, that'll print any record that contains the string fruit anywhere on it. So that prints out my apple, banana, kiwi, and mango. If I don't do the dash N, that prints out my fruits twice. Right, once because every record gets printed once, but if it's got fruit anywhere on the line, it executes that P command and it prints it out. So if I say slash fruit Q, that stops my program from running as soon as it encounters a fruit. Without a dash N, it printed out the first record because it always prints what it reads, but then it matched the pattern fruit, and so it quit. So if I search for a drink, right, this basically reads from my file and copies what it's reading up to and including the first time it finds a drink, and then the program exits. And here, if I did my dash N, I would get nothing, because by default, I'm not printing anything. So there's a case where we'd like to have the output appear. So here's an easy way to print the first 3 lines of a file. Just do sed without a dash N, but then have a program with one instruction in it which says if you're on line 3, quit. So it reads first line, prints, second line prints, third line prints, and then it matches our address, so it executes the instruction quit and sed exits. So more complex programs we can put into a file. So here's a 3-line program. It says if you're on line 3, print the line. If you're on line 4, print the line. If you're on line 4, quit. So that prints exactly lines 3 and 4 from my file. Right, again, this is hard to do in other ways, right? You could do this in C, you'd have to do a bunch of fgets. Make sure that your fgets is big enough that you're pulling in an entire line, or check that last character for a new line. And if it's not a new line, keep doing fgets till you end with a new line. Add a counter internally to keep track of what the line number is, and then if it's between 3 and 4, go ahead and print out what you got, possibly stringing together different pieces. It's a fairly complicated program, right? It's trivial in sed, right? This is what sed is for. It's for processing line by line in an input stream or a file. All right, so the command A is used to append something after the current line. I is used to insert something before the current line. Okay, this is the same append and insert command you have in VI, right? A starts from after your current cursor position, I starts before your current cursor position. So it's consistent with VI, like all good things. So here's another program. Says if you're on line 2, append the following. This was added after line 2. Let me make this uppercase so it's easier to see. So if you're on line 2, append this statement to the output, and then go ahead and print, regardless of what line you're on, right? There's no pattern for that second instruction. So we'll do the -n, -fp2 foods. And so it printed out the first 2 lines, and after the second line, it printed this message. This was added after line 2. All right, so here's a append after line 2 and also insert before line 2. Again, you may have to do this once a year, right? But if you've got it in your toolkit, it's handy. So we can do this with patterns. So anytime we have an input line that contains the word cookie, we're going to, I lost my eye. We're going to insert a message beforehand, and then we're going to append a message afterwards. All right, so now we got our cookies highlighted. All right, like so. And like most things in Unix, you can take long lines and break them into multiple lines by using a backslash. Right, so if I want to know the date, I could actually do this. Right, and it's a way to take something that might be really wide and sort of put it on separate physical lines. And so we can do this inside SED programs as well. And here I'm using this to throw some new lines in. So if I find a cookie, I'm going to insert a new line followed by, here comes a cookie. And if I find a cookie, I'm going to append, that was a cookie, followed by a new line at the end. And then I'm going to print the line. So that does the same thing as the previous one, but throws some extra white space in there. All right, another instruction that's really useful is W. W followed by a file. We'll write to a file. And if you do multiple writes to a file inside SED, they all get appended. So if I do this, I don't know if I can have a space there. Try it without. If I do this, it should match any record that contains the pattern cookie, and it should write that record out to a file called ha ha ha. And of course, SED by default copies from input to output, so I got a bunch of stuff on my output also. But if I look at ha ha ha, it's got a record of my cookies. And so if I had done this with a -n, I would get no output to standard out, but I still create this file. And let's just search for fruit. And now haha is a copy of the fruits in the file. And you could do this with a grep. Right? We could grep for a regular expression and put the output into a file by redirecting. But you can also do it with sed. And so let's see if we really need the space in there. Yeah, so the space is fine.
And those forward slashes are just there because you're finding.
Because I'm looking for the pattern, so it's a regular expression actually, which is cookie. So let's see if we can do this. So there's a 3-line sed program. Depending on what kind of pattern I match, I'm going to write to one of 3 files. So I'll run this on foods with a -n, doesn't produce any output, but there's our 3 files. Yeah.
What if my file name starts with like a P, D, Q, or I, or W?
That should be okay. I assume it's taking everything. Like that. Are you worried it's going to get confused with a print?
Well, like, even if it started with a W, like, I wanted to, I mean, if I was just trying to write to it, I guess,
I don't think it'll get confused.
okay.
Right, so there's my W meet.
Yeah, I was just thinking, like, if you wanted to include a file name and you weren't writing it specifically, instead of being like a file name, then.
Yeah. And I think you can, let's see if we can do a file with a space in it by backslashing it. Right, so, oh, we got weird backslash. Oh, that's weird. How would we do a space? We're in unknown territory here for me. Hmm. Okay, so apparently once you do a write command, everything after that is the file name, which is kind of cool to know. All right, well that was a weird file. All right, so you can split things like that. So if I do this, right, this is the way we've been using sed, just substitute /old/new. So if I substitute caret dot with nothing, right, that's just going to get rid of the first letter from each line. If I do a sed-i, that's not sed related. That's my weird laptop. So if you do a sed-i, it doesn't produce any output, but it actually edits the file in place. And with the -i switch, you can put it in a file extension and it will actually create a backup of your file before it edits it. So this will edit my file foods, but it'll also make a backup of the original. So that can be useful, and that may be useful in your reservations.txt processing. All right, the last thing is you can do an exclamation mark to negate a condition. So for example, 2, 4 print, right, that prints, let's just set dash in. 2, 4 print prints between lines 2 and 4. If I say 2, 4 exclamation mark, that prints everything except lines 2 through 4. Right, if I do /fruit, that prints every line that has fruit anywhere on it. If I do /fruit exclamation mark, that negates the condition. It prints all the lines that are not fruit. So that can be useful sometimes. So I posted an announcement right before class with some exercises just to think about. You don't have to turn these in, but play around with SED and think about how you could do some of these things using a SED program, just to kind of give you a feel for what this is capable of. Again, this is not something you're necessarily going to use every day, but there may be points where you find that you're doing a lot of heavy text processing, or you need to manipulate variables or things like that, and it may be that SED is exactly what you need. I mean, it really takes the place of cat and grep and bunch of other things, right? So if you know a few basics about using SED, really just what we've gone over, it can actually be a real powerhouse. So here's some things just to kind of think about. We can talk about these tomorrow. Plan for the rest of the week is probably to spend most of the time talking about processes. So looking at processes in Unix, how we create them from C, how we interact with them, how we control them, how we communicate between processes, and so on. Probably do that up through Friday, and then Friday we'll start PA5 presentations in class, which will take us Friday and probably part of Monday, and then next week's our last week, so we'll mostly be doing review at that point. We got a few other things to pick up, but we'll leave a few days for review. So we'll go from there.